So the internal angles in degrees of a quadrilateral are 12x plus 15, 17x minus 10, x plus 50, 15x plus 35. Find the value of x. All right, with this question, the key word here is quadrilateral and internal angles, right? So quadrilateral, we're talking about a four-sided figure, all right? All right, so a four-sided shape, which means that it has four angles inside. So the thing about a quadrilateral is that, one, we want to make note of the fact that the total internal angle, all right, of a quadrilateral is 360 degrees. So we have to at least know this in order to solve this sort of problem. So it means then that the angles that we got, for example, 12x plus 15, if we should add them up, plus 17x minus 10 plus x plus 50 plus 15x plus 35. If we should add up all of these four angles, it should equal to a total of 360 degrees. So that is the idea that we're going to be using to solve this problem, to rest our knowledge on the fact that the total internal angle must add to give 360. Now, with that said, we want to group the like terms. For example, 12x, 17x, x, 15x, they are alike. We want to put them together. Likewise, 15, negative 10, positive 50, and 35, we also want to group those. So let us go. 12 plus the 17, that's 29. 29 plus one more x, that's 30. And 15, we get 45x. So when we add up the x's together, we get a total of 45. Then now, you should be working with the numbers. 15 minus 10, that's 5, plus 50, that's 55, plus 35, we have a total of 90. So there it is, that on the left side, 45x plus 90, and this is going to equal to 360 degrees. Remember, the intention is to find the value for x. So we're solving an equation, ordinarily speaking. So we're going to be subtracting the 90 from both sides, so that we're left with 45x, which is equal to 270. Then what we want to do at this time is that we want to divide both sides by 45. And in so doing, we intend to find the value for x. So when we divide everything by 45, we end up getting 6, which means that the value of x is equal to 6. Conclusion, x is equal to 6 right there. The diagram below, not drawn to scale, shows 4 lines, POQ, OA, OC, and CD. We're told here that OA is parallel to CD. So we're seeing where they're saying that these lines, I'm putting in blue, and they are parallel to each other. All right. So we have those, and some angles are in there. We're looking at them. First question says that given, so I'm right here, it says, given that OA bisects angle POQ and that AOC is 62, so find the value of A. So they're saying here that the line OA, and you're looking at it, it's this line, bisects means to cut in two half. So it bisects POC. So it bisects POC. So all of that angle there was cut into two equal pieces. And so when it did that, this piece was 62. Remember, a bisect means it's going to be cut into two pieces. So what this means is that the other half is also 62 degrees because it was bisect. So the key word here is bisect, and that means to cut into half. So if one half is 62, the other half is also 62. Angle A though, angle A is between two parallel lines. So we will be looking at what is called co-interior angles. Now, co-interior angles, right? They exist between two parallel lines and they're on the same side, co-interior, so it's inside. They add to give 180. So if you say 180, take away 62, we're finding this other angle right here to be 118 degrees. Because co-interior angles, they do add to give 180 degrees. So A right here is equal to 180 degrees. For angle B now, for angle B, so we could just work angle B here. To find angle B, we can look at the fact that since this was bisect into two equal pieces, then this piece is also 62 because information came that angle POC was cut into two equal pieces. So now we realize that 62 and 62 plus the B, which would have been all of this, would add to give 180 degrees because a straight angle adds to give 180. So if you want to find angle B, you could add these two angles and take it from 180. And that will give us about 56 degrees. So angle B is 56 degrees. This one, no. One of those measurement questions, one has to take some time just to look. Right, it says for this question, you may find the following formulas relating to the cone useful. All right, so we're getting some formulas out. We're getting those out already. All right, and slant height. This slant height that you're seeing here, they're referring to L. L on the diagram is the slant height. This is the slant height right here, L. Right, that distance here. That's the slant height, right? All right, so they have L on that. All right, let's read it. It says, a farmer constructs a storage tank as shown in the diagram below. The shape of the tank consists of a cylindrical body of height 3.5 meters and a diameter of 8 meters. A conical roof of vertical height 1.2. So we're definitely seeing the shape. We're seeing all the information that we're given. Let us see what it is that they want. Calculate the slant height L of the roof. So we want to calculate the slant height. Now, the slant height, there is an idea that when you have a cone, the slant height, which is what I'm highlighting here in yellow, and the height of the cone, which comes from the apex to the middle of the cone, along with the radius, it forms a right angle triangle, and you're seeing it there. So then, if I can get the radius, understand that the diameter is 8. So if this is 8, it means that the radius is half of that, so that this distance would be 4 meters. So if I have that, then I am now able to find the slant height L by using the Pythagoras theory. Now, as you could see, this is actually the longest side. So we could say L squared is equal to 1.2 square plus 4 square. 1.2 square. It's going to give us 1.44. And 4 square will give us 16. And we're definitely looking at 17.44. The value of L will be the square root of that. And so the square root of that will give us, I have 4.18 or 4.2, depending. Let us see if there was any form of instruction given. Calculate. So, all right, so 4.18 is okay for now. So my slant height, I could label it here as 4.18 meters long. So that is our slant height. The second part to the question says, assume that the storage tank is completely sealed. So that means it's closed off. And it is filled with diesel from an opening at the top. All right, so it's sealed off when you fill it up with diesel. Find the capacity in meter cube of the tank, inclusive of the conical roof. All right, so basically then, what we are asked to do is to find, having had these measurements, all right, we want to find the capacity of this, basically. We know that these are the measurements that we have. This is 8 meters. We got that. We know that. This is 4.18. This one is 1.2. And they gave us this as well. So we had all those measurements already. 3.5, right? So this is 3.5. But the question says, find the capacity. Now, the capacity is to find the total capacity. I'll just say the capacity of this is a combination of two things. One, it's going to be that capacity of the cylinder. And you want to add that to the capacity of the cone. Add those together and then we would have gotten the total capacity. The formulas are given. The capacity of the cylinder, we can find that by using pi r squared with the h. The capacity of the cone is 1/3 the same formula, pi r squared h. So the formula of the cone and the cylinder, it's the same thing, only that the cone is 1/3 of it. So let's put it together. Pi was giving us 3.14. The radius of the cylinder is actually 4. And the height of the cylinder, this is 3.5, 3.5. And if we want to work out the capacity of the cone, 1/3 pi, same R, but the height is different for this one. It's 1.2. So we're paying attention to the capacity of the cylinder plus the capacity of the cone. Now the rest of it is make sure that we don't make any errors. So 3.14 times 4 times 4, that's 16, times 3.5. And this is 175.84. And this is meter cube. For the cone, 3.14 times 4 times 4 times 1.2. And there it is. We have gotten 60. Well, we're going to have to divide that by 3 because it's 1/3. So we are actually getting 20.1. And this is meter cube. So what we want to do is to add everything. 175 plus 175.84 plus 20.1. And the capacity is 195.94 meter cube. So that's the total capacity, which is to first find that capacity of this cylindrical part. Capacity of the cylindrical part. And you want to add that to the capacity of the cone. Put everything together, yeah, and would have gotten that final thing right there. So that's the capacity, you know, and the capacity refers to the space that can be filled, can be used interchangeably at times with volumes, the same calculation. Show that the total curve surface area of the tank to the nearest square meter is 140. All right. So we're talking about the total curved surface of the tank to the nearest meter. All right. Curved surface is the tank we're talking. All right. So it's a combination of two things. Curved surface of the tank. Let's look back at the original diagram. The curved surface is the outer part of this, and it's not gonna be including this because this is not curved. This is the flat part of the cylinder. So these two parts are out of it. What we're referring to is the curved part, the roundish part, right? So then we can put together some ideas here, as you could see. Now, there is a formula up here for the curved surface of the cone. So it is pi r slant height. See it here? So you get pi r times L. So we have those measurements. And it's going to give you the curved part for the cone. Right? And then now we want to find that as well for the cylinder. So let's look on the ideas. Curved surface. Let me write down this. Curved surface of the tank. We're going to talk about one. It's going to be the curved surface of the cylinder plus the curved surface of the cone. That's all. Now the curved surface of the cylinder, as we say, is simply So they didn't give it that. It's the circumference, which is 2 pi r times the height. So one has to just make note of that. So the curved part of the cylinder is the circumference of the cylinder times the height. For the cone, it's pi r. L, and L refers to the slant height. They gave it that formula. So we got this one from them, but we had to create this for ourselves. We weren't given that one. Now let's look at the two measurements that we have. Pi is pi, so 2 times 3.14. The radius is the same, 4, and the height of the cylinder is 3.5. For the cone, pi is pi, 3.14. The radius is the same, and the L, we got 4.18. So talking about putting back together all the information. The rest is calculate 2 times 3.14 times 4 times 3.5. And I'm getting something like 87.92. Pi RL 3.14 times 4 times 4.18, and I'm getting something like 52.5. Now if we add these together, 52.5 plus 87.92, we actually got 140.42, and they did say if you round it off to the nearest meter square, you see that you'll get 140 meters square. So all that you did right there was actually spot on, because we got back exactly what they want us to prove. Prove that we would have gotten 140 to the nearest square meter. All right, so there you could see these ideas coming out. Remember, curved surface, there are straight formulas there. They won't always give you these, but definitely one needs to remember them in order to go forward. All right. Now, the follow-up question says here that the farmer wishes to paint the exterior of the tank, given that 1 gallon is approximately 3.79 liters. So 1 gallon of paint covers 30 meter square of surface. Determine the amount of paint needed in liters, right? All right, to completely paint the exterior. What we're gonna have to take into consideration is that the curved surface alone is not the exterior. There is one circle. If you go back to the diagram, let's look at it. The exterior would be everything that we did, which is the curved surface. Because imagine that this thing is sealed. You will be looking at a triangular curved thing at the top, and then that round circular thing going around, which you know what the cylinder is. The only thing that we need to add to it now is the bottom that it is standing on. This was missing from the calculation because we were not finding this. So now we're going to have to think that, hey, in order to find all the surface to be painted, because they did say exterior, we're going to have to think about the part that it will be resting on. So we're going to have to find the area of the circle to be added to the 140, and then we would have had that total exterior surface area. All right, so let's go for the area of the circle first. So let's look at the exterior, right? Exterior surface would have referred to the curved surface plus, all right, so I'll say curved surface area plus area of circle. Now we already agree that this is 140. Now we're gonna have to find the area of the circle, which is pi r squared pi r squared. Put it together. So that's 140, 3.14 times 16. All right. So basically, we're looking at 140 plus 50.24. And this comes up to 190.24. So for the exterior surface, when we added the area of the circle to it, then we're looking at 190.24. And this is square meter. We were now told, now we're going to have to go back in our reasoning. So this is the surface that needs to be covered and in paint. And then we're saying that 30, they're saying 30 meters square, 1 gallon would have done that. So I can use the 30 now to find out how many gallons I would have needed. Or in other words then, 30 would actually tell me how many liters as well, because 1 gallon is equivalent to 3.97 liters. So if I divide this by 30, I am technically getting out the number of gallons that is needed. And then I could convert my gallons to liters. All right, so let us find the number of gallons. So the number of gallons needed will equal to this 190.24 if I divide this by 30, because 1 gallon can feed 30. So 190.24, I divide this by 30, and it's telling me that I actually need 6.34 gallons. That's the amount that I need of paint. But now 1 gallon is 3.79 liters. So if the question want the answer in liters, so the number of liters needed is simply to multiply the 6.34 times 3.79, which is the conversion rate for 1 gallon. 3.79 times that 6.34. And it's approximately 24.0. So I'll just say 24 liters of paint that will be needed to actually paint everything. So we need 24 liters to actually do the painting.